Okay, so this is the last section that we're going to be talking about in the chapter for chapter three. So what I want to do is talk a little bit about the Venn, what a Venn diagram is, because we're talking about unions and intersections. So the key word for this is when you're looking at when you're talking about the intersection, you can see here, the intersection would be the like I guess the purpley. The purple area, that's what they have when two sets have stuff in common. The union would be the stuff that is the combination of the purple and the blue. Okay, so keywords, there's two symbols. One thing that looks like an upside down U, that's the symbol that represents and, so that's the intersection. And then the one that is U, looks like or a with a goofy looking U, that's the union, that's the or. So we talked about and or when we did the thing about compound inequalities. So if A is equal to 1, 2, 3, 4, 5, 6, and B is 2, 4, 6, 8, 10, what is the union of A and B? So if I were to write this, it would be A union B is equal to, and I would write a set like everything that's in that and an or, so it'd be 1, 2, 3, 4, 5, 6, 8, and 10. That's all the things that are in that. Now, if we wanted to see a Venn diagram of this, a Venn diagram of this would be okay. So here's A, and here's B, and the intersection of A and B are the things that they both have in common. So in this case, it looks like it'd be 2, 4, and 6. So I'm gonna put 2, 4, and 6 there. That's the union, or excuse me, that's the intersection, and then everything else that's in set A that's not in B as well. So I have 1, 3, and 5. All right, because 3 and 4 and 6, or yeah, 2, 4, and 6 are in there. And over here I have 2, 4, 6, and then out here is 8, 10. So that's what the Venn diagram of this is going to look like. Since we're talking about that, disjoint sets have nothing in common. So if you want like a Venn diagram of what disjoint sets look like, here's an example. This is one. This is A, and here is B. So if we're looking at that, if set A was something like 1 and 2, and set B was 3 and 4, this is what they're. These are two disjoint sets. Okay. Moving right along. Okay. How about this? If m is equal to the such a set such that m is a positive factor of 24 and n is a positive even number, what is the intersection of m and n? Okay, so if I had to think about this, when I'm thinking about the positive factors of 24, it might help me to make the actual set. So the positive factors of 24, 1 and 24, 2 and 12, 3 and 8, and 6 and 4. The nice thing about sets is they don't have to be in specific orders. And then n, a positive even, n is a positive even number. This would be 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, dot, dot, dot. I did that on purpose. So when I'm looking at the intersection, M intersection N, that's the and. What is in both sets? M and at the same time N. I guess that would be 2, 4, 6, 8, 2, 4, 6, 8, 12, and 24. There is your intersection of that. All right, now another good example that can help you. This is the other side of your guided notes. Is when you're talking about intersections and unions, you're talking about compound inequalities have unions or intersections. So if we look at like the graph of this, you've seen these before. The x is less than -5, or x is greater than 5, and then the -5 is less than x is less than or equal to 5. You've seen these graphs before. So when we're looking at something like this, 32 is less than t is less than or equal to 4. What we want to do is we want to try to graph that. Okay, we want to try to graph that. So if we are going to graph those things, we have to be mindful of what it looks like. So that first one looks kind of like the and. So if we did this, you'd have a 32 is here and 40 is here, and you got a solid, solid. There you go. Right? This one, -4 is less than r minus 5 is less than or equal to -1. You could actually solve this simultaneously. If I add 5 here, add 5 here, and 5 here, I have 1 is less than r is less than or equal to 4. So this graph, 1, 4, open circle, close circle. Okay? Not too difficult. Looking at a couple other ones, here's 5t is less than or is greater than or equal to -20, and 4t is less than or equal to 24. When we're doing something like this, you want to go ahead and solve it. So we're going to divide by 5. We're going to divide by 5. We get t is greater than or equal to -4, and you divide by 4. You divide by 4. T is less than or equal to 6. Okay, so the for this, what we have to do is, instead of graphing them, what we can do is we can write them as an intersection, because it's the and. So it says t is great. So you could write this as t is greater than or equal to -4, and t is less than or equal to 6. There is your example with intersection and ands. Looking at the next one, here's one with or. Well, you can solve this. You subtract 3, so you get 4v is less than -8. You divide both sides by 4, so you get v is less than -2. And then this one you subtract 7, right? And you get -2v is less than -6. You divide both sides by -2, but you got to switch that inequality sign. So v is greater than 3. And the key word here is or. Okay, so if you had to do this, you would set this up as curly bracket here. V is less than -2 with the union symbol. V is greater than 3. Okay, let's take a look at one more that is not in your guided notes, but I think is important, and that is if we took a look at the absolute value of 2x minus 1 is less than 3. First off, if we go back to when we're looking at this, is this one involving the and or the or? That's right, this one involves the and because it's less than. So we're going to go 2x minus 1 is less than 3, and 2x minus 1 is greater than -3. And we go ahead and solve this. So we're going to add 1 here, and we get 2x is less than 4. You divide by 2, you get x is less than 2. And at the same time, you add 1. So you get 2x is greater than -2. You divide by 2, and you get x is greater than -1. And the key word is and. So if we had to write this out using interval notation, you could just say, okay, here we go, something like this. You could say x such that x is less than 2, intersection x is greater than -1. And on the other examples, I forgot the x such that the set x is that. But that's okay. We can go back and fix it. In fact, I'm going to go back and fix it right now. So if we put this one, this is going to be, if we're going to fix it, might as well do it right. So with that one, we would just say, we'll just go ahead and say v such that v is less than -2 or v is greater than 3. Going back to the other one, this one we can fix that as well. And we'll say that, whoops, we'll say that we have to go t such that t is greater than or equal to -4, and at the same time t is less than or equal to 6. So I know this one went a little bit longer than normal, but a lot of information here. Hopefully, if you have any questions, pause the video, go back and look at it. Please, pretty please, do your guided notes. Have a nice day. See you in class tomorrow, and may the force be with you.